is recorded, so therefore you will have a possibility to download this video if you like, and all materials this presentation will be sent to you by email representative included in this presentation and materials. The lecture itself is free and the materials are on the public domain, so therefore you can share these materials with your colleagues or friends if you like. So let's start. Strange. You can see my face, it's my photo. Thank you for your time this evening. Welcome to UML Essentials webinar. It's just a 1 hour webinar and it's quite short understanding of what UML is. It's the first time for me when I held a webinar, so please be tolerant. And I'd like to add that English isn't my mother language, so there can be mistakes in my speech and I'm a little bit nervous, but I will do my best. Excuse me for that. Let me introduce myself just in a few words. My name is Julia Martinovich, so you can call me just Julia, and you can send me questions if you like. And I'm from Kyiv, Ukraine, and I'm a lead business analyst, and as well I worked as a system analyst, and currently I'm working for one Ukrainian company called Zora Labs. There is no company name, it doesn't matter. Totally, I have been working as analyst, I think about 7 years. My primary responsibilities are requirement gathering, system analysis, business analysis, reporting, documentation, etc. I work in all fields of requirements engineering, from planning to change management, from vision to detailed technical specification. As well, I took part in several, not several, but more I think, conference, and was in committee of organizer in several IT analyst conference. Sorry. So let's start with what is the content. What I will talk about. I will talk about background of unified modeling language itself. I will talk about general of UML diagram concepts. I will talk a little bit of object and class diagrams and their difference. And as well, I like to mention interaction diagrams. And as an example of interaction diagrams, we will speak about sequence diagram. Just a few words about use cases and tools and links, useful links, so you can educate yourself later. UML background, I'll try to pay more attention to practical part of the webinar. So I will show you an example and will give you some homework, and just hope that you will do it. Because the more you train, the more you can. And the use cases, we will work on several use cases, I think we will see. So, what is UML? Really, I read a lot of materials about history of UML and UML development, and I think it's not a topic for our lecture. So all the history of analysis technique development, as well as modeling techniques origin, I will skip. And I don't want to talk about some standards and their difference. What is UML? Universal Modeling Language is a modeling notation. It sounds strange, but I will explain it later. And I'll try to explain with what is UML is not. When I was younger, at the beginning of my career, I thought what UML is not. It is not a methodology. It was my mistake to think that UML is all I need, and it's methodology, and it tells me what to do and how everything should be done. UML is not a technique. There is no strict way how you should draw your UML diagrams. And UML as well is not a tool, it's well known. So, what is UML? UML is not a methodology. As an example of methodology, let's get business back. Sorry. As an example of methodology, I can provide rational unified processes, which use UML and, for example, integration definition for functional modeling, idea of zero, and the functional modeling methodology. So methodology is just a bigger tool that helps you to create all necessary diagrams, all necessary documentation. It just suggests you the process to follow and products development. And it tells you what you should be done and how it should be done. On the contrary, UML diagrams, like any other diagrams, can be used as you like, as you need. You just have a tool how to draw your diagrams. It's just a language how you can do it. But nobody tells you that you have to draw all the 15 diagrams for each your project. You can select any diagram you want and create such, for example, just class diagrams, and that's enough for you. So UML is just a language and you can use it how you like. But methodology is it's a gathering of practice, best practice, and some rules how should you create your diagrams and your documentation. For example, Oracle created his own methodology, and methodology of Oracle tells you what exactly should be done to achieve your goal more efficiently and more quickly. So Oracle has its best practice. It's unite all the materials they have, all the best results they have, and then he gave you a result of their experience, and you can use it for your project. But UML it's not. UML is not a technique. Universal modeling language is just modeling notation. As I told before, UML is just basically only diagrams and supporting text. It's just a name of the diagrams, a special view of the diagrams, a special presentation of the diagrams, and some text which describes what these diagrams mean. It's just a set of instruments, and it can be used to document information about the subject you need. So some information can be important, and you need some more detailed diagrams on one level, and some information is not important, so you don't need, for example, some interaction diagram, because there is no difficult or meaningful or important interactions in your system. So UML is not a tool. It's clear because it's just a notation. For example, Microsoft Visio, it's a tool. It's a drawing tool, and you can just take some icon and put it on the screen, and then unite with some connections. It will be the diagram, so it will be some tool where you can create your notation, not diagram. And to you as well, you can use your Paint, but it's not so convenient as UML tool, for example, Visio. But you can use it, so you are not restricted to some special tools. You can use UML where you want and how you want. I'm not sure that almost modeling tools support UMLs, but I think most of them, yeah, most of them right. Because UML becomes some universal language. In my practice, I try to use not UML, but for example BNP, and I was told by my customer that he doesn't like it because he didn't know what I mean with my diagrams. He wants to have UML diagrams because it's understandable for him, and he knows just it and don't want anything other. So it depends not just on your needs or maybe some special task you have, but on the practice you have in your project and the customer, yeah, depends on the customer. Sometimes UML does too much, but often it's not sufficient. Really, when you try to use it everywhere you faced with the problem that it's not convenient, and sometimes it's more quickly and better to create some diagram in some other tool. For example, entity relation diagrams is more convenient to create in other tools, not in just in UML. And I suppose that really when I told to analysts on the conference, during several conference analysts, every, I think, seconds analyst doesn't hear anything about other model notation. It's great pity, really. Before you start to use UML, just try to understand that UML covers all your needs, and it's really what you need, because there are not alone. It's not only UML. There are a lot of modern languages, but UML is most marketing and very well-known notation. For example, business process modeling notation, I like it, BPMN, and business process execution language as well. It's really interesting. You can try and you will see some problems can be solved there more efficiently. What is UML? UML is general purpose model language. I told you a lot of material before. In other words, it's standard language for specifying visualization and constructing and documenting artifacts of software systems. I agree with just a standard language, yes, a universal language, yes, like English. It's not sometimes not. It's more convenient to use French, but everybody knows English, and you used to use UML. Also, UML is generally used to model software system, but really it's not limited just within IT boundary. It can be used everywhere as well for engineering and maybe constructing, I don't know, manufacturing unit, etc. But nobody knows about that, I think. We remember UML is just a set of diagrams that can be used and text describing that. A picture sometimes worth 1,000 words, and that's absolutely true about UML as well. There are a lot of goals UML is used and understand, but it's more important to define modern language which all IT guys can use and simply understand, that I told before. It's some universal language you can speak and everybody can understand what you mean. UML diagrams is not made for just developers and end user, and anybody interested can understand it, but it's sometimes not really user-friendly, really. And I think the person without special knowledge, it will be rather difficult for him or for her understand what you mean with your diagrams. So UML goals, it's to be a tool, not a tool, notation which is most universal and understandable for everyone. So like English language, for example. Two views of model. I think it's some views of the model. What I want to add. I'm not sure, but I think static and dynamic view of the model of UML model, was taken just from the earliest version of UML, and now you can see even more. Not here. It's strange. I haven't added this. I skipped this. But there are not just two views of model. It's the most simplest way to describe it. The static or structural view of diagrams, which captures the static behavior of the system. That's static, not behavior, the static view of the system. So class diagram, as well as domain object model and object diagram and all other diagrams. Dynamic, it's quite understandable. I think it's you can understand yourself that dynamic view of the diagrams represents the dynamic behavior of the system. It's important to understand that diagrams is partial graphic representation of a system model. It can't describe everything on one diagram. So don't try to describe all the classes you have, all the domains you have in one diagram. It's a problem of many analysts, developers, to create just a huge and not understandable diagram, and everything is described here but nobody can understand. It's useless. When you create a diagram, you should understand that more than, I think, 10 diagrams, it's not convenient and it's not understandable. Nobody can understand it without special, I don't know, knowledge of the system. But in that case, it won't achieve its goals, because diagrams should show the common view of the system. So when you create your diagram, you should understand on what level you create it. If it's high-level diagram, it should include just high-level classes. And that's all. Just high-level entities which are common for the system. And when you want to add details, you should create more diagrams and it should be more detailed underneath. It's great to use, please, if you have time, read some basis in the business process model and notation, BPMN. I mentioned it before because it tells you how you should place your elements on the diagram to be understandable. Okay, static view and dynamic view. Static view emphasizes the static structure of the system using object, attributes, operations, and relationship. And structural static view includes class diagrams and other structure diagrams. And later we will discuss class diagram and object diagrams. Dynamic or behavioral view emphasizes the dynamic behavior of the system by showing collaboration among objects and changes of the internal status of an object. This view includes sequence diagrams, activity diagrams, and state machine diagrams. But you can see in the literature not just two view but more view. For example, some deployment view, some really don't remember. I think there are four views in later version of the standard, but you can find it. I will give you a link to the standard and you can find all the information about that. The main that there are two views. There are basic views, static and dynamic. All diagrams you can write, you can draw. So from the left you can see static diagrams, structure diagrams, and from the right you can see behavior diagrams, which shows you, represents you, the behavior of the system. You can use activity diagram, use case diagrams, interaction diagrams. I really have never drawn state machine diagram. I really don't know what does it mean. Maybe it's for some special tasks and problems can be used, but really I don't know. Timing diagrams, we won't have these diagrams in our webinar, but it shows it uses the times, for example, for some email generation. So the time you start, for example, at the 1 a.m. in the morning, you should start some process that sends all the emails you need, and then after that this process initiates another process, and also depends on time. So timing diagrams, it describes your process which which depends on the time. And in detail we will speak about sequence diagrams and also as well as class diagrams and object diagram. More details about view. Oh, I've told you about it. Logical view. It's another I don't know, view of UML model. So it's divided into 4 views and you can use. So logical view, it shows how functionality is designed inside the system. So I think this logical view can be also called a static view. It's our static view. The same class diagrams can be included here. And as well, logical view shows you dynamic behavior. The component view, I think it's also the part of the static structure because it uses the component representation of the system. But component view is more about code. It's not, I think analysts won't face with this diagram, this kind of diagram. Concurrency view shows concurrency in the system, addresses communication and synchronization challenges within the system. This view can be represented with some sequence views, some interaction views, so not views but diagrams, sorry, and deployment view. I think it's understandable that deployment view shows this deployment of the system into some physical architecture with some computers, some devices, etc. I think it's partially dynamic behavior because it should show the dynamic behavior of the system. I will skip details of such categorization and which diagrams belongs to what category because of lack of time, sorry. So let's deep into class diagram. Class diagram is a basis. I think it's a class diagrams, it's start point for UML. It's considered like a prime diagram type. Yes, and I'm completely agree with that because during my practice, the more diagrams I draw, it was class diagrams. It's just a foundational diagram describing the system in the whole. So when you start your project and when you start to draw your project, you should start with this class diagram. It provides you with initial set of notation elements that all other structure diagrams use. So, for example, you have some system and you have to start to describe it. You should start with some objects will be shown in this diagram. Which part of the words will be implemented by your system. So you should start with this diagram to understand what part of the word and what domain will be shown, will be implemented later, and what goals will be achieved. The main purpose of class diagram is to show the types being modeled with the system. And types class diagrams can include not just classes. It can include interfaces, data types, components. So you can use class diagrams as, for example, component view. For component view, you can use also class diagrams, but it's just another view on the system from another angle. So classifiers in UML 2.0 are class, interface, data type, and component. What icons you will see on the class diagrams? It's class, interface, data type, and component. So you can see class diagrams can contain not just classes. All mentioned above are artifacts of object-oriented programming, so there is nothing new here. UML uses special name term for these types, classifiers, but I have never seen it before. Just class interfaces and that's all. Generally speaking, you can think of classifiers as a class, but technically it's more general term. So let's consider the following example. It's my example, which can be used and used later as an example for modeling. Often I hear the questions from developers that should we use modeling? Is the game worth trouble? Why would we waste our time for modeling and understanding what you draw? During my lecture, I'll try to find the right answer. In fact, there are a lot of good reasons to draw. When you draw, you represent your ideas and you understand what you don't know. You create some right questions to customers and figure out some dependencies that are not clear from the first sight. So you can consider the system as a whole and you can build more effective solution. In this example is pretty funny, I think, to slay a dragon. It's not difficult at first sight, but let's think about the best solution and how to minimize the risk of being killed by the dragon. So nobody wants to be eaten by a monster, by a dragon. So our goal of the system, perform a feat and slay the dragon. Class diagram. So as I told before, class diagrams is the basis of UML. So you should start with the class diagrams. I'm sure that you have heard about domain model and you have seen domain model, and maybe somebody knows what does it mean. But you won't find UML domain model in our diagrams, diagrams. So there is no domain model here. And how can we draw our domain model? What diagrams should be used here? The answer is very simple, it's class diagram. So class diagram can be used to draw domain model. Instead of domain model, sometimes class diagrams is used, but sometimes it's not. To represent the vocabulary, main entities and key concepts of our future system, the class diagrams is used. And domain model is just a first presentation of the system. So main entities and main classes which will be worked, proceeded in the system. Let's draw a simple domain or class diagram for the dragon to be killed. In the picture you can see just a representation of dragon entity. So we have interface. As you know, class diagram can include interface, component, let's check, class, interface, data type, and component. And here I used just interface and class diagrams and class. So my first homework here to check this diagram and maybe to add some attributes here and maybe some operations, because I think this domain diagrams is pretty simple. It can't describe the whole problem. So class golden dragon inherits the attributes and behavior from another class, pre-existing, called base class. In our example, it's dragon class. In its turn, class dragons implement the interface called beast. Each class should have its name, and optionally it can include attributes and operation. Sometimes when I draw a really huge domain model, I try to skip not sufficient attributes and sometimes all operations, because it just shows the interactions and some relations between the domain's objects, not objects, classes. Sorry. So it depends on the details you want to show. If your system is not so big, you can add all the details in one diagram. So it will be all the attributes, all the operations here. But if it's big, you should just show the main idea of the system and main domain object, main domain classes. Sorry. About relationships. I will skip this this part of lecture about relationship, but please read about generalization, association, and other, because not very often analysts pay attention to the difference between them, and the result, the diagrams are wrong and awful. And here is your homework, real homework. We have a hero, so a knight who will kill this dragon. Please draw the domain model for a hero and send me the result. Create a class diagram for a hero who is able to slave the dragon and wants to marry a princess. Please do as much detail as you can and send me the results. Let's talk about object diagrams. Object diagrams is pretty simple and similar to class diagrams, but it has the difference. And do not be confused with object diagrams. We can call object diagrams a special case of class diagrams. UML object diagrams is similar to class diagrams notation, and it can be used to illustrate the instance of a class at the particular point in time, or some variables. So some classes with some variables can be called an object. Please read carefully about an object. You might want to draw an object diagram to illustrate real example of a class or its relationship. Object diagrams can help to clarify classes and inheritance of it. It's also very useful when your system is pretty hierarchical, and you need to draw the instance of your system, not instance, maybe the view in the time of your systems, some layer of your system, and some inheritance in some perspective. If you are using UML modeling tool, you will see that Object Diagrams toolbar uses some of the same icons as Class Diagram toolbar. For example, in Microsoft Visio, you won't find additional grouping for object diagrams. You can just find some object icon on the toolbar. So use, please, this icon and use the association that are described in the standard UML 2.0. I think the latest standard in UML is 2.2, but I'm not sure, and 2.0 is the most common. And you can read in my slide that UML object diagrams use the same notation, pretty the same. object diagram represent an example of a class? Yes, an example in the one in time. So in particular time, it's just a snapshot of the instances in the system and their relationships. The most important part here are the relationships. If they are too complicated and depends on the time, it makes sense to create an object diagram. Our golden diagram. So here is my following home task. Next home task, to draw object diagram for the dragon and the knight. Here is the dragon. He's a golden dragon. He's called Jer. So his name is Jer. You can see his photo. So now you'll know how it looks like, and I hope it will help you to create an object diagram. And please, there is a mistake here on my object diagrams. Check my diagram and create the same diagram with the relationship. So you should use your class diagram for a dragon to create an object diagrams, and please use your imagination, and it's just a game. You should think about like you are modeling a game, and you have some classes to be implemented, and you have just a common vision of the game you will provide. So just model, just start, do it, and you will get interested in the result. So in my example, Jer, it's an instance of golden dragon. There is no relations in my diagrams with this object and others, and you should complete these diagrams using class diagrams drawn before. So the second homework is based on the previous one. Feel free to correct my diagram if I missed something or did it wrong. Let's go. So we pass through class diagrams. Class diagrams, that's the main class basic diagram. In UML, it's static diagram. It's used for modeling the system in a whole. And we mentioned domain model, which is drawn using class diagram. And please read carefully and detailed about domain model and how it should be represented, how it should represent the system. And then we switch to object diagram, which also shows the static view, static behavior of the system. Not static view of the system, yeah. And let's go to sequence diagram. Sequence diagrams, it's a subtype of the interaction diagrams. Let's go to our hierarchy. So, our diagrams in UML. From the left, you see structure diagram. We learned the class diagram and object diagram. From the right, you see behavior diagram, and now we are talking about the sequence diagrams. It's at the end of the diagram, so sequence diagrams is here. Underneath behavior diagram, it's a subtype of interaction diagrams. We will talk about that later. And also a few words about use case diagrams. So let's switch to sequence diagrams. The purpose of sequence diagrams can be described as to capture dynamic behavior, it's clear, of a system, and to describe a message flow. Don't be afraid with this sentence, message flow. It's just calling just the sequence of initiation of classes, objects in the system. And sequence diagrams should be used to describe sequence of messages. And why I'm talking about sequence diagrams, it's all from my experience that all I did, it was class diagrams. Not all, but mostly. I draw class diagrams, object diagrams, as well as sequence diagrams, and maybe sometimes state diagrams. And so I'm talking about the diagrams I draw more often. So sequence diagrams is also interesting because it's used very often, and you will see it if you will try to understand the existing system. You will face, I think, for sure with such diagrams. So sequence diagrams is a subtype of interaction diagrams. So I decided to tell you about that. From the name interaction, so sequence is subtype of interaction. It's clear that the diagrams used to describe subtype of interactions among the different elements in the system. In this interaction behavior is represented UML by 4 diagrams known as, just go back quickly, sequence diagrams, communication diagram, interaction overview diagram, and timing. And just a few words about sequence. Not few, but sequence diagrams emphasize on time sequence of messages. So the initiation of the objects, how they appear in the system. The following things are identified clearly before drawing the sequence diagram. So before starting to draw the sequence diagrams, please make sure that you clarified all the objects that take part in this interaction, the messages which will flow among this object, and the sequence in which these messages will flow. I took just an example from the internet of some order management system, because really my idea was to show you in life how to create sequence diagrams, but here is no video, unfortunately, and that's why I will try to explain in the words how it should be drawn. Just see this diagram, and I will try to get back to my example with the diagram. Let's look at standard sequence diagrams and create new one for dragon, knight, king interaction. So the sequence diagram shows the sequence of messages which pass between objects. Sequence diagrams can also show the control structures between objects, but I won't tell you about that stuff. For example, lifelines, it's the lines that goes from, for example, customers and down. This lifeline shows the life cycle, the time when this object exists. The communication, for example, we will think about communication between dragon and knight, for example, the servant. A knight, our hero, can't live without his servant, and the dragon somehow interacts with the knight who wants to kill this dragon, and dragon doesn't want to be killed, and a servant who helps his hero, his master. So they interact with the messages between them. And for example, a knight see our dragon. So our initiation will be when the main problem you should start what exactly not use case, but interaction you should show. I will try to describe you, for example, an interaction with a first, I don't know, first meeting with the dragon. So the time when the knight at first sees this dragon. So initiation of my sequence diagram will be at knight saw the dragon. So it will be, I don't know, knight. The first object will be the knight. This particular knight, it's not a class, it's an object. So this particular knight, in this time, he saw a dragon. And our initiation calls a dragon. So we created a dragon as an instance of our golden dragon class. And the message, the dragon, I don't know, maybe cries very loudly and calls his wife, dragon's wife. I don't know, use your imagination and tries to create the process that will be maybe the battle or the meeting when all this object will be created and used, and some actors will, not actors, the classes will appear, some will disappear. Just use your imagination and let's try to draw an object here. Just try it for the first step. You should start. You should understand which event will call the first figure, the first object here, and which object will appear here. All the objects will be drawn on these sequence diagrams. In my example, it was a dragon, a knight, a servant. So I will have 3 objects here, but maybe dragon wife, and then you should think about the interaction between the objects. Which objects initiate which one and with which message. They interact, and they interact with some messages. I don't know, crying, or maybe a servant gives a knight a sword, and knight tries to beat a dragon. So there will be operations or messages that are one object sent to another one. Let's do it. So practice, use your imagination, and I'll be waiting for your results. Use case. Just in a few words, because we don't have much time. Sorry, unfortunately. Use case. When you start to work on any system, at first you should draw a class diagram. Not exact. Maybe sometimes domain model is enough, sometimes it's not. It depends on your system, on how your system is, how complicated your system is. And then when you finish it with all main domain classes, domain model and class model, you should think about an actors. Who will be internal or external agents, and who will interact with your system. Think about what actors can exist in our modeling example. So use case, it's an example, not example, it's a type of diagrams which describes, just a moment, behavior diagrams. So you can see use case diagrams, it's a subtype of behavior diagrams, and it describes on the high level, not sometimes on the high level, it depends really, sorry. At the beginning you can use case as high level representation. So sequence diagrams, it's more reasonable to be used at the level of detailization. But when you just start your project, it's enough to use class diagram, maybe some parts, in some cases object diagrams, and also you need use case diagrams. You should start with them. Use case diagrams, in common, generally speaking, it describes the main usage, the main scenarios that your system will execute. So what your system can and how it reacts to different events from internal agents and from external agents. So in our game, main use case, the first use case you will draw, it should be discrete that corresponds to your goal, to the goal of the system. The goal of the play of this system is to slay the dragon and to manage the prince. I don't know, maybe just to slay the dragon. So main use case is just to slay the dragon. And then you should think how it can be implemented. And then on the second layer you will have not just one use case, but more use cases. How this process, how this result, this goal can be achieved, and what actors will take part in this use case. In UML, there are several diagrams available for model dynamic nature, and use case diagram is one of them. Use case cannot be just drawn like a picture. When you describe use case in very detailed, you can describe use case with the text, with some basic flow, some alternative flow, some functional requirements. But in the beginning, it's very good to see the system in the whole, and in that case you need to show the dependencies of your use cases. So your main use case consists of more smaller use cases, and these small use cases interact with each other, and some includes smaller and so on. So detail, you go from the beginning, from the one huge goal use case, and then detailed it later. And sometimes it's not enough to show just in a picture, but it's more convenient to use text to describe your use case. So in my practice, there are a lot of use cases that are written in text and also have a graphical representation as well. So two sides of use case. But let's go back to our lecture, to slide. Use case dynamic nature, and describes the dynamic nature of the system. And this use case describe the scenario how the system can be used by an actors. Use case diagrams consist of actors, use case, and their relationships. So some actor can initiate some use case, and some use case can call another use case, and so on. These diagrams, use case diagrams, is used to model system and subsystems of application. A single use case diagrams capture just a partial functionality of the system, except with just a high-level use case, which can describe everything, just your goal, but very common. Use case diagrams are considered as a high-level requirements analysis of a system. And as I told you before, it's just a graphical representation what your system do and how it depends on external systems and what it's not do. So the use cases show the boundaries of the system, what the system can and what it cannot, sorry. So when the requirements of the system are analyzed and functionalities are captured, it all should be described in use cases. And also what I have to add and what I need to add, don't put in use case the graphical design, so UI, because I faced with the problem that many analysts add the graphical, for example, name of labels, buttons, and graphical elements, and it's wrong. It's completely wrong, because use case should use the scenario, and scenario should not depend on the UI. Sometimes it's rather difficult to create a use case that doesn't depend on UI, but you should try. And you always should think that if designer one good morning will completely redesign his view and his mockup, your use case should work and should be applicable and good whatever he draw. And actors can be defined as something that interacts with the system. Within the system, somehow initiates the use cases, and who or what can interact with your system. When you answer this question, you will give the list of, you will understand the list of actors. Actors can be a human user, but sometimes it can be just a time. It's not really good to use time as an actor, but sometimes on time some reports are run on time, and you should show that this use case run report on wake up a dragon will be initiated by time, or by sunrise. Sunrise helps the dragon to wake up, so sunrise initiate dragon's wake ups, and it depends on time. So this use case, dragon wake up, initiated by an actor, but this an actor is not a human. It can be time. So, in a brief, when you are planning to draw a use case diagram, you should have the following items identified. Functionalities to be represented in this use case. So what scenario should be done? And actors who can initiate this use case. And as well, don't forget about relationships. Your use case can be initiator for another use cases. And relations between use case and actors are really important. Don't forget about them. And our webinar comes to end. And really, when I try to find all the tools and utilities, there are not a lot of free tools here in the list. The first is Microsoft Visio. It's not really convenient to use Microsoft Visio, but sometimes you have no alternative. I'd like to mention as well StarUML. StarUML is open source project to develop fast, free UML platform, UML diagrams on Windows. So really I tried StarUML, but the format is not well known and not all customers like it. All other stuff in my list I have never tried really. I have heard about Umbrella and that's all. I just took this list from Wikipedia. So on Wikipedia you can find the comprehensive list of UML tools and utilities. And maybe some of them are more convenient than Microsoft Visio. And useful resources. The first on my list is Object Management Group. It's the site where you can find the description of the latest standards. So this Object Management Group is responsible for creation and development these UML standards. UML at Wikipedia, it's clear. It's good tutorial on UML, really. But there are, I don't like the structure of this material, but it's rather convenient. If you know what you want to find, you can find it. And also UML.org, it's a listing to various other UML resources. So you can use it like your roadmap to UML. And also my contact info. You can please do this use case diagrams, draw your use case diagrams for dragons, class diagrams. It's a very funny example, but when you do it, you see what you don't know and you have to read it more and more, and you practice. And the more you practice, the more you can try on simple examples, and eventually you create a more complicated one. And you can understand that you did something wrong and not clearly. When you create a right diagram, you like your work, you like the result, and it removes the difficulty of the system when you do it's correct, I think. So you can download UML tutorial, but it's rather huge. And really, I'm not sure that I know everything from UML tutorial. But my advice to start with review of main diagrams. So don't try to read everything, just to try to start with main diagrams and try to draw diagrams yourself. And you see the funny picture, and my advice, do not take everything as a rule, because if you use everything very strictly, you will get the results you see on the screen. So many diagrams, and not all of them are necessary, not all of them are important, and not all of them are needed. So don't take UML too seriously. Just think out of all your needs and system restrictions. And from the beginning, answer a question: does UML covers all your concerns? Is it best solution for modeling in your case? And good luck. Thank you for your time. Now it's time for question. But really, I don't see any questions. Maybe I did something wrong. No questions? Oh, I don't understand something. So thank you for your time. Nobody asked anything. Goodbye. Take care.